Hi everyone and welcome back. Now in today's video we are going to go ahead and discuss about an important topic in Terraform, which is plugin caching. This again, as we were discussing, is an important topic, and in many of the use cases, even in your local workstation, you might want to implement it and it has its own set of benefits. So let's go ahead and discuss about the challenges first, post which we'll be discussing the benefit that it provides. Now at this stage, we already know that whenever we configure a TF file, one of the first commands that we have to run is the Terraform init. What does the Terraform init does? It downloads the appropriate provider plugins in your local project directory. Now, although this looks good, however, there are certain issues with this specific approach. And the issues are that the provider plugins that you download, it takes little amount of time. And along with that, sometimes the size of the provider plugins are also quite large, and this leads to increased bandwidth usage. For example, this screenshot depicts that a provider plugin of HashiCorp AWS is being downloaded and installed. Now, if you look into the .terraform directory of the project, the size of the plugin is around 616 MB. Now, does this mean that whenever you do a Terraform init, total of 620 MB for the provider of AWS will be downloaded from the internet? And the answer is no. In such cases, there is an important role of compression that comes into picture. So behind the scenes, you will see that Terraform is downloading a zip file, which is a compressed file associated with a provider plugin, and then it uncompresses the file and the actual plugin is made available to you. So let's do one thing, let's go ahead and discuss about both of these pointers, post which we'll be discussing about other things in detail. So for today's video, I am in the KP Labs Terraform folder. Again, we do not really have any files here. I'll open with Visual Studio Code. Let's create a new file called as provider.tf, and within here, I'll just declare a simple provider of AWS, and that's about it. I'll save this. Now, when you do a Terraform init, let's quickly do that. So it is downloading and installing the provider plugins. So the Terraform project has been initialized. Now, if you look into the .terraform folder, let's look into the properties. It's 616 MB. In fact, if you go inside the provider of AWS, if you look into the actual application here, this is the main plugin. Let's look into the properties. The size itself of this file is 616 MB here. So this is the first part. The second part that we are going to learn is associated with the compression and how we can see the exact size of the compressed file so that it gives us better understanding on how things work. So for this, let's go back to our KP Labs Terraform folder. I'll just delete the files that were created earlier. And what we are going to do, let's open up a new terminal. This time we are going to set the tf_log environment variable to trace. Now note that this is a Windows specific command. If you are using Linux, then you have to replace set with export. Alright, so it will be export tf_log is equal to trace. Again, you can make use of different log level also to get the details, but we are just using trace for simplicity. Now, once it is set to trace, when you do a Terraform init, you'll get much more better information. And what is the information that you need? You need a HTTP GET request that Terraform must have made to fetch the AWS provider plugin. All right. So let's quickly find that out. So you can search for the GET request, and this is the one that we are looking for. All right. It is not the short 256. It should not be the SIG. It should be without that. All right. So this is the one. Now, again, if you're using a different operating system, you will not really see Windows AMD 64. You will have a different path, but the overall approach would be something similar. It should be providers HashiCorp AWS, the version download. So I'll copy this and let me add it here. So this is how it really looks like. Now I'll just do a pretty print here so it's easier to view. Now within here you have the download URL. This is what is important and this is what gets downloaded behind the scenes. So I'll copy this and I'll add it here. And you see this time one file has been downloaded. So let's quickly wait for this to complete. Alright, so now you see the size of this compressed is 137 MB. So there is so big difference between the uncompressed size and this compressed file. So let's do one thing, let's just copy this file just for reference and I'll add this uncompressed file over here. Alright, so if you just open this, you see it has the actual provider plugin that we were discussing and the size of the uncompressed plugin was 616 MB. So now coming back to the second pointer that we were discussing, that by downloading the plugins, it can lead to time consumption and also increased bandwidth usage. Now again, it is not necessary that a project will have only a single provider plugin. Project can use multiple set of provider, and when multiple set of providers are used, the overall size of provider plugin can also increase in such cases. So nowadays, for many of the users, the bandwidth usage is something that is not a constraint because they have fiber connection. However, that is not the case for everyone. Along with that, sometimes what happens that even if you have a good connection, the provider plugin download takes time. Why? Because ultimately it's been downloaded from the internet, which is the registry.terraform.io page. What happens if the website is slow? In such case also you will have to wait for the download to complete. This is one area of concern. The second area of concern is that when you're speaking about the cloud environments, cloud environment does not really have unlimited bandwidth usage. There are restrictions. For many cloud providers will charge you for the overall bandwidth usage and the amount of data that you consume. And this is the reason why we have to address both of these constraints, which is the time consumption constraint, the bandwidth usage constraint, and see what are the options that are available. Now, HashiCorp has provided multiple options to address both of these issues, and we will be discussing each one of them. In today's video, we are going to discuss about the option number 1, which is the provider plugin caching. So at a very high level overview, the plugin caching feature, it allows Terraform to store the provider plugin binaries in a local cache. Now again, this has a benefit. However, let's understand this with a diagram where what you need to do is you have to create a cache directory in your local laptop. And this cache directory will have all of the provider plugins that you generally use on day-to-day basis. Now, once this is completed, whenever you do a Terraform init next time, instead of connecting to the internet at a registry.terraform.io page, Terraform will go ahead and connect to this specific folder in your local laptop to check if the provider plugins are available. If they're available, it can fetch it and use it accordingly. If it is not available, then it can go to the registry Terraform IO page and fetch it from the internet. So this is the basic concept about the plugin caching. Let's go ahead and quickly look into it from a demo perspective. We are going to have a separate practical video associated with the plugin caching. However, at this stage, I just wanted to show you from a demo perspective so that our concept is clear before we do the practicals. So going back to our KP Labs Terraform folder, nowadays many a times we have seen that many of our students, what they'll do, since they might be practicing multiple set of topics together, what they'll do, they'll just create a separate folder, something like this. And in this folder, they might have some different TF file. So I just copy this for simplicity. And we know in order to test things out, the provider plugins needs to be downloaded. So instead of doing a Terraform init, again to download the entire compressed file, what they'll do, they'll just copy the .terraform and the lock.html to the project number 2 just for simplicity. And that's about it. Once you have done that, you can directly go with the Terraform plan, something like this. You don't really have to do a init again. All right. So this is one approach that many of the students follow. Today, we are going to discuss about a slightly different approach related to the plugin caching. So let's do one thing. Let's go ahead and delete all of these files. Now I'll quickly configure my environment for plugin caching. Again, note that this is a demo video. Once environment is set up for plugin caching, then we'll see on how the workflow works. So for today's video, I have a folder that I have created locally called as plugin-cache. So this is the folder. This is the cache directory folder where all of the plugins will be available for you to use in a subsequent Terraform init runs. Now I have the plugin cache feature that is enabled. Now when you do a Terraform init, I just wanted to show you at this stage you do not have a .terraform folder here, and even the plugin cache folder is empty. So now when you do a Terraform init, so first time it needs to download the appropriate provider plugins. This is an important requirement for plugin caching, because if you do not download it, you will not be able to use it as part of the subsequent runs. So let's quickly wait for the overall project to be initialized, and it has been done. Now at this stage, we have the .terraform folder with the appropriate plugin, and now you see even in the plugin cache, you have a copy of the provider plugin that got downloaded that is available. So if you will see, this is the actual provider plugin that is made available. So once the provider plugin is available in the plugin cache, for other subsequent runs, in fact, let's just do a project -2 and I'll copy the provider.tf in this project 2. Now, if I open the terminal, generally, if you do a Terraform init without the plugin caching enabled, again, it will download from the internet. But this time, it has not downloaded from the internet, and you will realize that Terraform init was so fast. It took like 2 to 3 seconds for everything to be completed. Now, how can you identify whether the plugins were not downloaded from the internet and it were fetched from the plugin cache? And for that, you need to read the events that have been described here. The important one is this one, which states that using HashiCorp AWS from the shared cache directory. So this is the event that says that, okay, it was able to find it from the cache directory and it has directly fetched from there here. Alright, so I hope with this at a high level overview you understood the importance of plugin caching feature in Terraform. Now at a later stage, when you have 100 projects that you have created as part of your local laptop, it becomes so easier, because for all of the 100 projects, ultimately the provider plugins are coming from cache directory. Not only it will save you time, we were just seeing that it just took 2 to 3 seconds for the entire Terraform init to complete, and it will also save you the bandwidth usage. And in case if you do not worry about the bandwidth usage, as we're discussing, in case if the registry site is slow, then even in such cases, it will save you good amount of time in the overall download process. So that's a very high level overview, and with this we'll conclude today's video.